All right. Good morning, everybody. Today we're going to be doing a brief measuring view, and then I'm going to have you take a quiz on this measuring unit that we have been doing. The purpose of today's target is for you guys to assess your level of understanding when it comes to measuring. Specifically, what that means is I'm going to give you problems that ask you to do things we've been doing over the past couple of weeks. And while you're doing it, I want you to determine if you actually know the answers to those questions. Or maybe you're just guessing lucky and getting them right. Or maybe you get confused by a problem or something like that. But I want you to try and determine, based off of your answers to these questions, do you understand the material? If the answer is yes, great, you're ready for the quiz. You'll do great. If the answer is no, that means that you need some more practice, and you should come into office hours to get that practice. Additionally, if you have any missing assignments, doing those assignments is a really great way to review for a test. All right. So what's going to be on this quiz test? I use the two terms interchangeably. This assessment is going to be about a dozen questions. And I'm going to ask you to basically do three different things. I'm going to ask you to identify different types of lab equipment. I'm going to ask you to measure a line with a ruler, similar to how we did in the alternative lab, where, or at least half of you probably did in the alternative lab, those of you that chose to do the alternative lab, where you've got a ruler and you've got a line and you need to measure that line. So there'll be questions like that where you're measuring in centimeters and millimeters, and you'll see examples of that in today's review. And then just questions on other forms of measurement. So on Monday, we briefly talked about measuring temperature, mass, and volume. So I'll ask you things like what tools, what pieces of lab equipment do we use to measure those things? And, what kind of units do they have? What is the unit of mass? Um, Admittedly, we haven't gotten as much practice with that last one, so you'll be seeing more emphasis being placed on the previous two bullet points than the last one when it comes to our quiz. All right, without further ado, let's hop into these practice problems. And remember, today's target is for you to assess, do you understand them? And if you don't, seek help. Okay. All right, first one, starting off nice and easy. Which of the following is a beaker? All right. The correct answer is A. This is well, okay, I hesitate to say the most commonly used lab material, but pretty much every lab that we do during a traditional school year, in pretty much every lab I run, has beakers. Beakers are really great at just holding large amounts of liquid. That's why we use them. Graduated cylinders, on the other hand, they're really good at accurately measuring liquid. So when you need to accurately measure exactly like 17 milliliters of liquid, you can use a graduated cylinder for that. This is called an Erlenmeyer flask over here. It's really good at preventing chemicals from hopping out of the container. Sometimes steam, vapor, and chemicals pop a little bit as they are cooking. And in those cases, we use an Erlenmeyer flask, but otherwise they don't get a whole lot of use. And then test tube tongs are used to hold test tubes. Okay. All right. Which of the following would you use to measure mass? The correct answer is triple beam balance. So you've probably used a triple beam balance before, and mass is simply measurement of how much stuff something has. So we could take a cell phone or a comb or a relatively small object and put it on the scale and move the weights around to determine how much stuff there was. How much cell phone is in your cell phone? How many grams of cell phone do you have? That's what this triple beam balance could tell us. The mass, how much stuff there is. Which of the following would you use to measure the volume of a liquid accurately? And I actually gave you this answer on a previous problem, but is it a beaker, an Erlenmeyer flask, a graduated cylinder, or a crucible? It is a graduated cylinder, C, graduated cylinder. And the reason is because it has all these nice little tick markings on it. And so to the nearest tenth of a milliliter, we can very accurately measure the amount of liquid. Let's say I want 19.5 milliliters. You could go right here halfway. It's hard to see on the screen, but this is 19, this is 20. Halfway in between 19 and 20 would be 19.5. So it's a really accurate measuring tool. Okay. We got a decent amount of practice with this. You'll definitely be seeing a few problems asking you to measure the length of certain lines and objects in centimeters and millimeters. See if you can do that now. With this problem, I think it's a little bit easier to start with the centimeters instead of the millimeters. So let's talk about it. These big ticks, these are centimeters, right? So here's 5 centimeters, here's 6 centimeters, which means each of these ticks in between is 0.1 centimeters. So this is 5.1, 5.2, 5.3, and here's 5.4. And you'll notice that our line is almost at 5.4. It's close, but it's not actually at 5.4 yet. It's somewhere in between 5.3 and 5.4. It's not exactly in between, right? If it was exactly in between, we would say 5.35. But because it's a little bit more than halfway, we'd probably say something like 5.37, 5.38. I would even accept 5.39, okay? Because it's closer to 5.4. And that can be difficult for people to understand. 5.39 is the nearest number to 5.4. So we know it's not 5.4, but just a little bit less than 5.4 is 5.39. Okay. So what about millimeters? Well, it's relatively easy to just convert centimeters to millimeters. All we have to do is multiply by 10. So if we have let's call it 5.38 centimeters, since that's kind of in between the numbers I would accept, 5.38 centimeters multiplied by 10, shift the decimal point over once, shifting it to the right means we've got 53.8 milliliters, 53.8 millimeters. Another way you could check that would be to just check all these little ones and count them individually, or go by tens. 10 millimeters, 20 millimeters, 30 millimeters, 40 millimeters, 50 millimeters, 51, 52, 53. Okay, it's somewhere in between 53 and 54. We can go with 53.8 because it's almost 54, but not quite. All right. What about this one? The line, it's kind of right over here in case you missed it. What is the length of the line in centimeters? What about millimeters? All right, let's go over it. So this one is probably going to be easier to do in millimeters first. So, and that's just because we don't have very many, it's not a very long line. So this little tick right here is 1 millimeter, 2 millimeters, 3 millimeters, 4 millimeters, and 5 millimeters. So this one looks like it's exactly halfway in between 4 millimeters and 5 millimeters. So we're going to go with 4.5 millimeters because it's halfway, 0.5 millimeters in between 4 and 5 millimeters. Okay, so 4.5 millimeters. What about centimeters? Well, centimeters for this particular problem, all we have to do is take the number of millimeters and divide by 10. So if we have 4.5 millimeters, we've got 0.45 centimeters. A great way to check your work is say, okay, looks like we've got a little less than half of a centimeter. 0.45 is a little bit less than half of 1. So 0.45 centimeters is also the correct answer. Okay. If you need additional practice with this, the alternative lab section is a great place to go. I'd be happy to provide you with an answer key to that if you would like it. Just email me. Okay, so this was in our PowerPoint slide on Monday. And in the PowerPoint, I said, make sure you know what a meniscus is. So, is the meniscus A, B, or C? Okay. The meniscus is B. The meniscus is simply a curve that occurs in water. It happens because of surface tension. The water likes to kind of hold itself onto the lip of the glass a little bit, and it causes this curved effect as the water kind of hugs the side of the glass. Should you measure from the top or the bottom of the meniscus? Should you measure from the top or the bottom of the meniscus? Remember, the meniscus is this curve, right? So are we measuring from the bottom of the meniscus or the top of the meniscus? We always measure from the bottom of the meniscus. And the reason for that is just because of error. you're going to get a more accurate measurement when you're measuring from the bottom of the meniscus than you are from the top. Because if you measure from the top, you've got all of this air that you're including in your volume. And if you're measuring from the bottom, that kind of gets factored out by any air bubbles or things that could happen to your liquid. And it's less water than there is air. That's another way to think about it. Less water than air. So in any event, you don't want to remember why. Just remember we measure from the bottom of the meniscus. Which of the following is a unit of mass? Gram, meter, liter, or Celsius? The answer is gram. Grams are the unit that we get on our handy dandy triple beam balance. You can't see it very well in this picture because I've zoomed it out a lot. But the triple beam balance measures things in grams. Kilograms are also a unit of mass. Basically, anytime you see that prefix of kilo or centi or milli in front of something, it's just the base unit. Like we've got centimeters, which is just 100 meters, like there's 100 cents in a meter. Or we've got millimeters, like 1,000 years in a millennium, milli, right? But gram is just the base unit of mass. Okay. Which of the following is not a unit of volume? Centimeters cubed, kilograms, milliliters, or liters? So the correct answer is kilograms. Kilograms, like I said on the previous slide, is a unit of mass. Okay, that concludes our review question, or our review questions, I should say. I'd like to take a moment and just remind you guys of our target. You should be able to assess your level of understanding when it comes to measuring. Do you understand the questions that we did? Did you understand them when we did them? Or did you need to hear me tell you why the correct answer was the correct answer? If you need more practice, please come into office hours. Tests are very important. I have what's called a weighted grading scale. And what that means is that test points are more important than regular assignment points. It is more important to do well on a test than it is to do well on an assignment. You want to do well on both, right? In order to get an A in the course, you need to do well on assignments and tests. But tests are the most important form of point because that's where you're really proving what you've learned. Okay, talk to you guys later. Bye.